Okay, welcome to this video where we're going to be having a look at a paper 3 practice paper for the foundation tier exam. Now, as always, you can get back to this paper by scanning the QR code on the front, and you can access all of the different questions through the chapters feature within the video. I've got a lot of questions to get on with, so we're going to get started straight away. So this one here, we have question 1, which is writing down the value of the 3 in 16.35. Now this is looking at place value. Now when we are looking at this, there are a few different ways to explain that position, but when it is in this decimal position here, it is in the tenths position, the 5 being in the hundredths position. So if we have a 3 in the tenths position, the best way of explaining that value there would be to say that it is 3/10. You could also write that in words, and there are other ways to write the answer here, but I think the safest method when you are writing down that value is to say the 3/10. If it had asked us for the value of the 5, well, that's in the hundredths position, and that would be 5 out of 100. But there we go, there's question 1, 3/10. For question 2, it says to write 0.19 as a fraction. Now, typically, a lot of these decimals, when you're writing them as fractions, can actually just be typed into your calculator. And if you type in 0.19, it will usually write that as a fraction for you. However, if your calculator doesn't have that function or that ability to do so, then we'll take the similar approach to what we did above. This decimal finishes in the hundredths position, so it is out of 100. And we have the 1 and the 9 there, and that is 19 hundredths. So there we go, that is our fraction, 19 over 100, as our final answer. Now for question 3, it says to write down 2 factors of 35. Now there are lots of options we can have for 35, and if we write down the factor pairs, then we can just pick 2 of them. Now the easiest factor pair would be 1 multiplied by 35, and that would be the easiest pair of factors that we could write. I'm just going to write 1 and 35. There is another factor pair we could choose. We have 5 times 7, and of course you can mix and match those numbers as well. So I could pick 1 and 5, or 5 and 7, or 7 and 35, whatever pair there that you are looking for. But of course, just making sure that we only write down 2 factors and not all of them. And there we go, there is our factors question. This next question is looking at solving a one-step equation, a relatively nice one, but you might be thrown by this 10.5 written on the right. Now that means something divided by 4 is equal to 10.5. And to reverse that process, we would just multiply both sides by 4, and that would give us x is equal to, and of course, whatever it's equal to is going to be our answer. So 10.5 multiplied by 4 on the calculator comes out as 42. So our final answer is 42, and that is the value of x. That is the number that when you divide it by 4, you get the answer 10.5. Question 5 here is looking at a list of numbers and asking us to write down a cube number. Make sure you don't confuse a cube number with a square number. You have a button on your calculator for your power of 2 and for your power of 3. So worst case scenario, just write them into your calculator. 1 cubed is equal to 1, 2 cubed is equal to 8, and so on until you hit a number in this list. Now the next number is 3 cubed, and that is equal to 27, and 27 is within our list. So 27 is a number that we could choose. However, there is another cube number in this list, and that is 4 cubed, which is equal to 64. So you can pick either one of 27 or 64, but one of those answers is given, as it only says write down a cube number. It doesn't say write down all the cube numbers or the cube numbers, it just says write down a cube number. So there we go, there are our cube numbers. Not to be confused with our square numbers, there are lots of square numbers in this list as well. You have 2 squared is 4, 3 squared is 9, 5 squared is 25, and you also have 8 squared, which is 64. So you have a lot of square numbers in there, possibly trying to throw you in that question because you tend to recognise the square numbers more so than you recognise the cube numbers. So just use your calculator for that if it does mention cube numbers. And there we go, either 27 or 64 would have been a fine answer. Now this next question says a shop sells pens at different prices. The cheapest pens in the shop cost 27 pence. Lottie buys 18 pens from the shop and she pays with a £10 note. If Lottie buys 18 of the cheapest pens, how much change should she get? Well, here we are buying 18 pens and each one is costing 27 pence. So straight away we can do 18 multiplied by 27, of course writing our working out down, but typing that into the calculator, and it gives us 486 pence. Of course there are 100 pence in £1, so if we divide this by 100, we can turn this straight into pounds, which is £4 and 86 pence, and maybe including the pound symbol with that. Now she pays with a £10 note, and we want to know how much change she gets. So we want to do the £10 that she's paid with, take away the £4.86 that it's cost, and again we're going to type that into the calculator after writing our working out down, and that gives me a final answer here of £5 and 14 pence. Now we have a part B to this as well. It says instead of buying the cheapest pens, Lottie buys 18 of the more expensive pens. She still pays with a £10 note. How does this affect the amount of change she should get? Well, if she buys more expensive pens, even if they were 1 pence more expensive, well, 18 multiplied by 28 would actually be £5 and 4 pence. And if we take that away from £10, that only gets us now £4 and 94. So we end up with less change. Of course, quite a logical question there. If we spend more money, then we're going to get less change. So it says, how does this affect the amount of change that she should get? We would just say something along the lines of, Lottie will get less change. There we go, and that would be a fine answer. You don't necessarily have to back that up with working out, because it's a relatively logical one. Okay, question 7. Write a fraction in the box to make the calculation correct. Now, you can just type this in on your calculator, but of course, looking at that, we should hopefully be aware that the whole number 1 should be 10 tenths. So we have 10 tenths, take away 3 tenths, which leaves us with 7 tenths. Those two numerators there, in order to add up to 1, need to both add up to 10, as 10 is the denominator of the fraction. However, you can just type that into your calculator, and it would have just given you 7 tenths there. For part B, it says find the number that is exactly halfway between 1/10 and 3/5. Now, to find a midpoint of two things, you just have to add them together and divide by 2. And the fact that it's fractions doesn't change anything. So all I'm going to do is add these two together on my calculator. 1/10, add 3/5. You don't need to apply any fraction rules here because we are using a calculator. So I can just add them up. That adds up to 7 tenths. Or you could write that as a decimal, 0.7. And if we want to find what's in the middle, we just need to divide that by 2. Now, it doesn't matter which one you divide by 2, because hopefully it's already in your calculator. You can just press divide by 2, hit the equals button, and we can either write our answer as a fraction, which would come out as 7/20, or you could write it as a decimal, and that is 0.35. I'm going to write the answer as a decimal, even though the question is given to me as a fraction. It doesn't specify it has to be written in a certain way, it just says find the number that's exactly halfway. And both of those are just numbers, so 7/20 or 0.35 would be a fine answer. Okay, on to question 8. It says Ali, Ben and Kathy share an amount of money in the ratio 6:9:10. What fraction of the money does Ben get? Well, looking at these, I like to label the symbols or the letters for the people's names just above, and I can see that Ben is the 9. So if I'm going to write his amount as a fraction, well, he definitely gets 9, and then what's that out of? Well, we just need to add these up and find the total. So 6 add 9 add 10, and that adds up to 25. Just remember to use your calculator for these steps, don't make a little mistake there. Just because there's 3 relatively nice numbers to add up, just use your calculator, get the number right, and secure that mark. So there we go, 9 out of 25 is Ben's part. The next one is asking us to write a ratio in the form n/1. Now, I really like these types of ratios because I know the number on the right has to be 1. And this is just testing your knowledge as to how do you divide down to 1. Well, anything divided by itself will give you the answer 1, so we just need to divide by whatever's in that right position, or wherever the 1 is. In this case, the 1 is on the right, so we're going to divide by 2.25, and whatever we do to the right-hand side of a ratio, we will again do to the left-hand side. So 4.5 divided by 2.25 gives us the answer 2, and there we go, our ratio in the form n/1 is 2:1. So there we go, just a little bit of a knowledge-based question there really, thinking about what you divide by to get the answer 1, and that's just dividing by itself. For question 9, It says here, cornflakes are sold in 2 sizes of box. Ellie buys 3 small boxes of cornflakes and some large boxes of cornflakes. In total she buys 5,850 grams. Work out the number of large boxes of cornflakes that Ellie buys. Well, it's told us that she buys 3 small boxes. So to start with, I would want to do the 450 grams multiplied by 3. And that gives us a total on the calculator of 1,350 grams. Now the remaining boxes that she buys are large boxes, but it only says some large boxes. And of course we're going to work out how many that is. So let's work out how many grams are left. We buy 5,850 in total. She's already got 1,350 from the small boxes. So if we take those away from one another, 5,850, take away that answer, that leaves us with 4,500 grams. Now, of course, at this stage, you have 2 different ways of finding out how many boxes that is. We could multiply 750 by different numbers until we hit 4,500, or we can just do 4,500 divided by the 750 to see how many actually fit in. So divide by 750, and let's just type that in, we get 6. And there we go, so she buys 6 large boxes of cornflakes, and that would be our final answer. And there we go, a final answer of 6. Okay, so just using some units there and finding that missing piece. So for the next question, we have a scale, or a scale drawing, or a map scale here you might call it. Now this ratio here isn't necessarily a ratio that we have to think about sort of sharing in a ratio. It's just telling us here that on the map, 1 centimetre, for example, has a real life distance of 50,000 centimetres. Or in other words, in real life, it's 50,000 times bigger than it is on the map. Or of course, you could think about it the other way around. On the map, it's 50,000 times smaller. So here it says the length of the road on the map is 8.5 centimetres. So in real life, it's going to be 8.5 multiplied by 50,000. We're going to type that in on the calculator, and that tells us exactly the distance it is in real life, but of course, this is in centimetres. So it comes out as 425,000, and really important here, we label that as centimetres. Because the next part of the question here says to work out the length of the real road in kilometres. So to get from centimetres to kilometres, I would tend to do that in 2 steps. I would first jump down to metres. Now to get to metres, there are 100 centimetres in every metre, so we would need to divide by 100. So if we divide by 100, we can do it on the calculator, but that's just going to cancel off 2 of these zeros. So that's 4,250, so 4,250 metres. And then to get to kilometres, well, there are 1,000 metres in a kilometre, so we're going to need to divide by 1,000. And there we go, that's going to turn it into kilometres. Again, we can type that in on the calculator. Dividing by 1,000, we'll do 1, 2, 3 jumps. Of course, use your calculator though, and that comes out as 4.25. And there we go, that would be our final answer, 4.25. I wouldn't recommend jumping straight from centimetres to kilometres and trying to learn those different divisions or different multiplications, depending on which way we're moving. I would just learn the centimetres to metres and metres to kilometres. Not forgetting that word kilo literally means 1,000, so it means 1,000 metres. And most people tend to remember there's 100 centimetres in a metre, so just knowing that that word kilo means 1,000 can help with some of those conversions. Of course, when you're thinking about weights, you have kilograms, or kilograms, which is 1,000 grams. So there we go. That is our conversion there, and using a map scale, and just understanding that that ratio just means that it's 50,000 times bigger. On to question 11, we have a reflection, a relatively nice reflection as well, where we haven't had to actually find the mirror line. Not forgetting that if there was an axis, now this one doesn't have an axis here, but let's imagine that it did, and our axis along the x here goes up. And let's just imagine it's nicely scaled, so 1, 2, 3, 4, 5. Well, that line there would be called x is equal to 5. So obviously this one doesn't have one of those. Now if it does, you're going to have to find the line yourself. And if it's scaled and we have a horizontal line as well, let's imagine it goes 1, 2, 3, 4, 5. Well, you could be asked to reflect a shape in a line y equals 5 as well, which would be going across here. So you do need to know how to find these lines, even though this particular reflection is a relatively nice one. So we obviously don't need to think about that for this question, we just need to reflect it and then counting away from each point, doing one at a time. So 2 away, this one is 4 away, so that would go here. This one is the same distance away, that's 4 away, and then we have this one which is 3 away, and then you've got this 1 point here which is a little bit harder to count, but typically most people tend to like these reflection questions. Just make sure it is actually reflected, you've not just drawn it in the same orientation on the other side of the line. There we go, you can see it has reflected, it's facing the other way, almost like it's looking in a mirror. But there we go, there is our reflection. Next question, we have some algebra. We have expanding a bracket in our first question. So when we are expanding a bracket, just remember that we need to expand or multiply both things within the bracket. So we'll start with 2a multiplied by a. That gives us 2a squared. And then we have 2a multiplied by 7. And that gives us 14a. And we just keep that symbol the same. So keeping that plus symbol in between. For the next question, we are factorising. We are still going to keep that symbol the same, but factorising is almost the opposite. We are going to put it back into brackets. So here, we have to think, what does 14 and 7, what do they both divide by? Well, they both divide by 7, so 7 would go outside the bracket. And then we think to ourselves, well, what do we times 7 by to get 14b? Well, we have to times by 2 to get to 14, and we have to include the b to ensure that it actually makes 14b. We keep the symbol the same, and then just think, what do we times 7 by to make 7? Well, that's just 1. So there we go, we'll finish that off, and there it is, it's factorised, and it's back into brackets. Now there are 2 ways of solving this next equation, but typically if there is a bracket involved, I would always expand the bracket first. Don't just think, but because it's an equation, we're just going to straight away add the 6 to the other side, because at the moment it's locked away in that bracket. We need to expand it first. So if we expand the bracket, we get 9c minus, and although you probably know 6 times 9, just use your calculator for that. So 54, and that is equal to 63. We are now at a stage where we can add the 54 over to the other side. So 54 add 63 gives us 117. So we have 9c is equal to 117. And at this point, we need to divide by 9 to get c is equal to, and again, just using your calculator for this, 13. And there we go, that is our final answer. C is equal to 13. There are other ways that you can solve that. You can actually divide by 9 straight away, which does make this question quite nice as it's only one c in the bracket. If you do 63 divided by 9, you get 7, and it's just c minus 6 is equal to 7. And then you can just add 6 to the other side and you get c is equal to 13. So that's a slightly quicker way of doing it. However, I would advise always expanding a bracket whenever you see it. There's only one scenario where we wouldn't expand a bracket, and that's just straight after we factorise something, as of course we want to leave it in a bracket. Now our final question here is looking at a law of indices. Not forgetting, there are quite a few different laws of indices. You can have things like n to the power of 4 times n to the power of 3. That's where you add the powers, so that would be n to the power of 7. You can have n to the power of 4 divided by n to the power of 3. That's when you subtract the powers, and that would be n to the power of 1. But this one here is in brackets, and when it's in brackets, although it's a slower way of doing it, just remember that means n to the power of 4 times another n to the power of 4 times another n to the power of 4. And most people know when you are multiplying, you can add the powers, and 4 plus 4 plus 4 gives us the power of 12. Now the quick way of doing that is just to multiply these powers here, so 4 times 3 is equal to 12, which of course is the same as just adding up 3 4s. But there we go, when it's in brackets, multiply the powers, and n to the power of 12 is our final answer. Our next question is looking at some direct proportion, and of course this has some real life context. It says here there are 24 grams of protein in 100 grams of mixed nuts, and there are 12 grams of protein in 100 grams of yogurt. Rayanne has 60 grams of mixed nuts and 150 grams of yogurt for breakfast to work out the total grams of protein in this breakfast. Now, in order to work out, and let's start with one of them, let's start with the nuts. To work out how much protein is in 60 grams of mixed nuts, we want to know how much protein is in 1 gram. So here we can divide this by 100, and that'll tell us the amount of protein in 1 gram. So 24 divided by 100 on the calculator tells us that in 1 gram there is 0.24. There we go, in 1 gram of mixed nuts. Now we want to know how much is in 60 grams. So to turn this into 60 grams, we will then want to multiply it by 60. And if we just press times by 60 on our calculator, we get 14.4 grams in 60 grams of mixed nuts. It can seem a little strange here because both of them are in grams, which does make it a little bit trickier just to sort of process. But there we go, that is our first one. The next one is also giving us the amount of protein in 100 grams. So again, we'll divide this by 100. And 12 divided by 100 is 0.12. So we have 0.12 grams in 1 gram of yogurt. And we want to get to 150 grams, so we'll times by 150, straight away on the calculator, and that gives us 18. So we have 18 grams in 150 grams of yogurt. We then have our two amounts of protein. We've got the 14.4 and the 18 grams, and we just need to add those together to finish. So 14.4 plus 18, and we can add that up on the calculator, and that comes out as 32.4. So there we go, that's our final answer, 32.4 grams. So just making sure we find how much is in 1 gram, or whatever it is that we are talking about. In this case, we are looking at the grams of yogurt and the nuts there, so finding the total in 1 gram. Okay, question 14, we have a frequency tree. Now it says here 200 people live in a village. 23 people do not have a garden. We can actually put that in straight away. That would go into this section here. Now straight away we can actually work how many people do have a garden. We can do 200, subtract the 23, and that gives us 177 down here. We can actually go and tick these lines off as all those numbers are now in the frequency tree. It says 10 males do not have a garden. So at the do not have a garden section, we have 10 males that do not have a garden, and we have therefore must have 13 females that also do not have a garden. So we can tick that off, and now it says 95 people are male. So if 95 people are male, well, we have 10 in the do not have a garden section. These have to add up to 95, so therefore there must be another 85 down here. Again, just doing 95 subtract 10. We can then figure out how many females there are, because these two here have to add up to that 177. So I can do 177 subtract 85, again just on the calculator. There we go, and that gives me 92. We have now completed the frequency tree. Typically we'll normally be asked something about it. This one says one of the people who does not have a garden is chosen at random. So for the people that do not have a garden, we are looking at these 23 people. So it's specifically telling us we're picking one of the 23. Write down the probability this person is a female. We can see over here that there are 13 females, and we are picking out of those 23 people. So our probability would be 13 out of 23. And there we go, 13 out of 23. No working out needed there, just making sure we read the question carefully. This one specifically said we were picking from the people who do not have a garden, but of course if we were picking from all of the people, it would be out of 200 instead. But this one specified it was only picking from the people who do not have a garden. So there we go, there was a frequency tree and also a probability question along with it. Now our next question is asking us to draw a pie chart. Now the first thing when you are plotting a pie chart is to consider the fact that these numbers need to add up to 360 degrees. So the first thing to do is to add together these numbers in our table. Now if we add those together, they currently add up to 45. Now we don't want them to be 45 degrees because that's not going to fill our circle. So we want them to add up to 360 degrees, which is going to fill a full circle of a pie chart. Now to do that and to figure out what we need to multiply by to get to that point, we need to know, well, what do we multiply 45 by? We can figure that out by just doing 360 divided by 45, and that is 8 times. So in order to make all of these numbers add up to 360, we have to multiply them all by 8. So over here, just to the side of the table, I'm going to write times by 8, I'm going to multiply them all, and then we're going to have our angles for each section. So 13 multiplied by 8 gives us 104 degrees, 17 times 8 gives us 136 degrees, 8 times 8 gives us 64 degrees, and then 7 times 8 gives us 56 degrees. Now a quick check, if you add those all together, if they don't add up to 360, you've definitely made a mistake, but if we add them up, they do add up to 360 degrees. Now this next part, of course, you need to get a protractor for, and you may have a 180 degree protractor, or you might have a 360 degree protractor. Both are going to be fine, but ultimately we need to make sure that we are measuring from 0. So if we bring our protractor into the pie chart, lining up the crosshair with the centre of the circle, we can then plot our first amount of degrees, so that's 104. Now I am measuring clockwise here, so I'm going to use the outside numbers. I'm going to go down to 104. I'm going to mark a point there really clearly so that I can see where that's going to be. Now from there, you need to measure that using a ruler, and we need to make sure that is not going to be moved when I move this. So we'll mark a little point over here. Obviously you can keep it lined up perfectly on the outside of the protractor, not so easy for me on here. But once we've done that, we can now join that up using a ruler and a pencil. And obviously I'm going to connect it all the way to the outside there. It doesn't matter if you go over the pie chart as long as we've got those pieces drawn in properly. Now that was the first part of the pie chart, and that is athletics. So I want to label that. There we go, we've got that labelled as athletics. I now want to plot the next one, which is 136. Now when we are plotting the next part of the pie chart, we want to make sure that we rotate this protractor round so that it now lines up to our new line. So when I bring this down, I need to make sure that it lines up absolutely perfectly. And of course, we want to make this as accurate as possible. So we do want to make sure that we are really trying to make sure that that perfectly lines up. And there we go, 0 on top of that new line. So we can now plot that new angle, which was 136. Again, I'm going to use those outside numbers. So 136. Let's just have a look. So that is just here, if it lets me to draw it. Let's have a look, see if we can draw it in. Okay, it doesn't look like it's going to want to let me draw it. 136, I'm going to have to draw it quite a way out of the pie chart, but there we go. That lines up with 136. You can obviously just line it up really nice and clearly just below the protractor, but that's absolutely fine. I'm just going to have to do as best as I can here. Joining that up, there we go, and there's my next one. So that was cycling. And there we go, there's the next section of the pie chart. And the next one is swimming, and that is 64 degrees. Now, as long as all the other pieces are perfect, this next part of the pie chart should allow us to then not have to measure out that final part of the pie chart. However, we are just going to double check and make sure that it is the angle that we want. So I'm going to line this all up, making sure the 0 is pointing down my new line. And again, being really careful to make sure that that is perfectly lined up where the 0 is. Right, so I'll try and make this as best as I can. And there we go. So that's lined up nicely. I just need the 64 degrees, which for me is just over here. I can just line it up just about, and then I can draw that next line in, and then we are pretty much finished. There we go, lining that up. And that is swimming, which means that our final part of the pie chart is gymnastics. There we go, and ideally you want to put your protractor over the top of that, and you want to measure that last part of your pie chart just to make sure that it is absolutely perfect. It's okay if you are sort of a half a degree out or something like that. It's not a massive issue, but of course you want it to be as accurate as possible, and you want to just double check just to make sure that you're not 4 or 5 degrees out. And there we go, if I sort of line that up, there we go with the 0 on there. You can see that that final part of my pie chart is on 54, maybe 0.1 of a degree just below that, that's going to be absolutely fine, of course. I'm super close to 54, and there we go. I'd be happy with that pie chart, but again, this is all about accuracy when you are drawing a pie chart like this. So there we go, that is drawing a pie chart. Make sure that adds up to 360, and there we go. We can keep on with the paper. So question 16 says that Miley is organising a party. She spends £100 on food and drinks, £120 on a venue, and £80 on live music. Now straight away, before we even move on, we know we're probably going to have to add all of those together, as that's the total that she spent. But it says here Miley sells 64 tickets for the party, and each ticket costs £8.50, and we want to work out her percentage profit, and we're going to give it to one decimal place. So for percentage profit, we want to use our profit over the original and then multiply that by 100 to turn it into a percentage. It's a similar concept to when you are marking or scoring an exam paper, for example. A paper like this is out of 80 marks, so let's imagine you get 55. Well, you do 55 out of 80, the original amount of marks that you could have got, and then times that by 100, and that'll give you that as a percentage. It's a similar process to what we're looking at here. So here we want to know what the profit is. To work that out, we need to add all of these things together. That adds up to £300. And she sold 64 tickets for £8.50. So 64 times £8.50, which we can type into the calculator. So 64 times 8.5, and that is £544. We can now work out her profit, as we can do 544 subtract 300. And that is equal to £244 of profit. We can now just plug these numbers into our formula, which is the profit over the original. So the profit is £244, the original being the price that Miley spent here, which is £300, and then we're going to times that by 100. Not forgetting, it does want our answer to one decimal place, but we'll write down the full answer first, or at least a few decimals past one decimal place, and then we'll round it in our final step. So 244 over 300 times 100, and that comes out as 81.3 recurring, or 81 point and then lots of threes. Now if we're going to round that to one decimal place, we'll chop it after the 3 there. The 3 afterwards is not big enough to round it up, so that is 81.3%, and that is her percentage profit. So there we go, the profit over the original times 100, and that comes out as 81.3. And there we go, there is our percentage profit for this party. Okay, so on to our next question. So here we have some standard form conversions. So when we are converting into standard form, the number has to be between 1 and 10. So we want the decimal to go in between the 4 and the 6. We want it to be 4.68. We've got these 3 zeros at the end. So to get there, it's 1, 2, 3, 4, 5 jumps, or in other words, 5 multiples of 10 that we'd have to multiply back to get to 468,000, but we'd write our answer as 4.68 times 10 to the power of, and it was 1, 2, 3, 4, 5, so 10 to the power of 5. And that just means to get back to 468,000, we'd have to multiply 4.68 times 10 5 times. And there we go, that's just our rule of how standard form is written, has to be between 1 and 10. Now for the next question, it wants us to write it as an ordinary number, but we have 5.037, and it's a power of -4. So -4 is going to be a 0 point number. We have to jump it 4 jumps to the left. So 1, 2, 3, 4. That's where our decimal is going to go. Of course, if we jumped it to the right, it would be a large number, and a negative power is a 0 point number. So we're going to fill in all these loops. 1, 2, 3, tidy it up with 0 at the start. And we need to obviously rewrite this number because we do not want this decimal in this position here anymore, as it is now moved. We have 0.0000 and then 5037. And of course, writing that all the way up to that final whole number. And there we go, that is some standard form conversions. Question 18 is asking us to find the highest common factor. And we have the highest common factor of 72 and 126. Now, when finding the highest common factor, I would normally recommend, particularly when we have some slightly harder numbers, finding them as a product of prime factors. Now, you can write out the factor pairs. So we can do 1 and 72, 2 and 36, and keep on going and then test our highest factor. However, you can just use the factors button on your calculator, And for me, if I type in 72, and I'll link a video in the description so you know how to use this button on your calculator, but 72 is equal to 2 cubed, or 2 times 2 times 2, times 3 times 3. 126, if I type that one in, that comes out as 2 times 3 times 3 times 7. So to find the highest common factor, we have a look at what's in both. There's a 2 in both, there is a 3 in both, and there is another 3 in both. So all we do is we take those three numbers, 1, 2, 3, and we multiply those together. So for the highest common factor, we'll do 2 times 3 times 3, and on the calculator, if we work that out, that comes out as 18. And there we go, 18 would be our final answer. Now, if for any reason you don't have that factors button, of course, you can write them as a product of prime factors using a prime factor tree, or you can have a go at finding all the factor pairs like we've just started to do. Now, it wouldn't have taken you too long if you do 72 divided by 3 on the calculator. There's another factor pair, 3 and 24. You can do 72 divided by 4, which gives you the 18. You can then divide by 5. We can do 72 divided by 6. So that's 6 times 12. 72 doesn't divide by 7. Divides by 8 9 times. And there's all the factor pairs. However, when you do have trickier numbers like this, of course, that's a lot of factor pairs. So do make sure you use your calculator, just dividing in a nice logical order there. I divided by 1, then 2, then 3, then 4, and just wrote down any factor pairs that give me nice whole number answers. From there, we would look at dividing those numbers into 126, and you will find when you do that, that 18 is that first number that divides into 126 if you work from the biggest number downwards. So there we go. That is looking at the highest common factor. For part B here, it says a number n is rounded to 2 decimal places and the result is 4.76. Using inequalities, write down the error interval for n. Now, quite a lot of the time you are given the error interval, but you need to know what it looks like. You have the letter that we are using in the middle, and we have 2 arrows pointing to the left, and the left arrow has this additional symbol on it. Now, to find the numbers either side, which we call our lower bound and upper bound, we just do, for the first one, which is 4.76, when it's a decimal like this, you just need to stick a 5 on the end of it, and that's a really easy mark to get. To get the final mark, and again, you can sort of draw this as a sort of number line to visualize it. We'd have to zoom in pretty close to a number line, but you would have 4.76, the number above would be 4.77 if we were zoomed in close enough to see 2 decimal places, and 4.75 would be just before that. We are looking at the bounds in the middle, which is where it rounds, or inside that it rounds to 4.76, and the bound on the upper bound there, which we've already written down, is in between 4.76 and 4.77, which is 4.765, and on the left there it's between 4.75 and 4.76, and it's just 4.755. And there we go, that is our lower bound, 4.755, and there we go. Quite a tricky one there where we have 2 decimal places, but there we go, final answer, similar process to a lot of error interval questions. Question 19. We have the diagram shows a quadrilateral ABDE and a triangle BCD. It says here CB is parallel to DE and BD is equal to BC. Angle AED is 134. Work out the size of the angle marked X, and you must give a reason for each stage of your working. So the angle X that we are looking for is up here in the quadrilateral. Now we are also given a right angle over here, which we're going to want to label straight away. That is 90 degrees. Now straight away, because we have a quadrilateral there, if we knew the size of this angle here, well, we could do angles in a quadrilateral, which is 360, and find out what was missing. However, we have no way of working that out just yet. But we do have this triangle on the left, on the right. We have an isosceles triangle here, shown by those 2 lines on the triangle. Now when we have an isosceles triangle, base angles in an isosceles are equal. So here, below these 2 lines, the 2 angles underneath them are equal. So this one here is 58 degrees. Now it told us that we need to write a reason, so I'm going to label it next to the diagram, and I'm just going to put base angles in an isosceles are equal. There we go, and it's absolutely fine to label it on the diagram, just like I'm doing now. There we go, base angles in an isosceles are equal. We can now use that to find the missing angle in the triangle. So I can now find this top angle because I can do angles in a triangle equaling 180 and find that missing piece. So I can do 180, subtract the two 58s, 58 plus 58, and if I do that all on the calculator, let's have a look, 58 plus 58 is 116, 180, take away 116 is 64 degrees. So this one here is 64, and that's because angles in a triangle add up to 180 degrees. There we go, and I've written another reason down. I now need to think about how I can get into the quadrilateral. I'm still not quite there. Now there are a couple of different ways that we could do that. Now for starters, it has told us that we have these parallel lines. It gives us that as the first bit of information. And at the moment, we've not even used the parallel lines at all. So when looking at parallel lines, if we highlight the two lines that are parallel, being here and here, if there is a connecting line between the two, it will allow us to use things like alternate or corresponding angles. Now we want to be careful with this because obviously these two lines are connecting here, but not necessarily going to help us in terms of getting the one we're looking for. Whereas this line, which is cut through the middle, does create that nice Z shape. And when we create that Z shape, it forms an alternate angle. And these two here that we're highlighting that are almost hooked in by those two, if I sort of redraw this to the side, you might recognise this a little bit more, but you've got these two angles here. Now they are called alternate angles, and they are equal. So this angle down here is 64 degrees, and that's because alternate angles are equal. There we go, and there is another reason, and we've now used the parallel lines. And if we are given parallel lines in a question, we're pretty much not going to be able to get to the answer without at least thinking about them. So there we go, we are pretty much done. We can now look at the missing angle within that quadrilateral, and if we add together everything that we have, we need to subtract it away from 360. So we'll add together the 134, the 90, and the 64, and let's take it all away from 360 plus 64. There we go, that all adds up to 288, and if we take that away from 360, we get 72 degrees. And we could give one more reason here, and that's because angles in a quadrilateral add up to 360 degrees. There we go, quadrilateral add up to 360 degrees. Right, there we go. So there is an angles question looking at triangles, quadrilaterals, and parallel lines. Okay, on to our next question. Right, what was our answer there? 72. Let's make sure we write that on our dotted line. There we go, 72 degrees. Question 20 is a relatively nice probability tree. Relatively nice because all the branches are labelled for us. But of course, looking at these branches and remembering that these two on each branch need to add up to 1. Now at the moment, each one does add up to 1, of course. It's not asking us to identify a mistake, but just making sure you are aware that to get the missing number there, you would just subtract the one that you were given away from 1. This one here just says to work out the probability of winning both games. So to win the first game, we go up this branch. To win the second game, we would then go up this branch. The two decimals that we have passed through on that route is the 0.2 and the 0.3. And all you have to do is multiply those decimals together. So 0.2 times 0.3, the same process if it is fractions, and that gives us 0.06. And there we go, that would be our final answer. Do type that into your calculator, particularly when you have to use it. If there's fractions on a probability tree, type the fractions in on your calculator too, because all we need to do is type them in, the calculator will give us the answer there. So there we go, 0.06 was our answer to this probability tree, the probability of winning both games. On to question 21, we have some density, mass and volume. Now whether you use a formula or a formula triangle, just make sure that you write down your formula as soon as you see density. So here we have density is equal to mass divided by volume. Now this question here, it wants us eventually to work out the volume of the gold bar. Now to work out the volume, we have to do the mass divided by the density. So the mass is given to us, 12.5 kilograms, And the density is also given to us, 19.3 grams per centimetre cubed. However, you can see here that the mass is in kilograms and the density is in grams. So we need to convert one of them, and typically you'll convert the one which seems more logical to do, and in this case it's much easier just to multiply this by 1,000, which will turn it into grams. Again, not forgetting kilograms or kilograms is 1,000 grams. So there we go, 12.5 times 1,000, which we can type in on the calculator, is 12,500 grams. If we then put that into our division, we'll have 12,500 grams divided by 19.3. The units now match, grams per centimetre cubed. And if we type that in on the calculator, we get 647.6683938, and it wants me to give my answer to 3 significant figures. So the third significant figure here is the 7, which means we have no decimal places. So after the decimal there, we have a 6, so it is going to round up. So it's 648. And again, not forgetting that this was a volume, so that is a centimetre cubed, as that's the volume units that are being used in the question. That may of course be on the dotted line, which it is. So 648 is our final answer. And there we go, that was using density, mass and volume. And again, just remembering to write your formula down, or a formula triangle if that's what you use. But there we go, there is our density question. Now this next question is asking us to draw a frequency polygon. A frequency polygon is a really nice graph to draw because all we have to do is do a dot to dot. We just need to remember where to draw it. Now with a frequency polygon, we have to draw it in the midpoints, and that's the midpoints of each group. So here between 0 and 5 is 2.5. And of course, remembering to find the middle of two numbers, you can just add them together and divide by 2 on your calculator. But these are relatively nice ones. If you work nicely with decimals, it's pretty quick here to throw these midpoints in and just double checking, making sure they have the same distances between them so don't make a mistake, and they do. So there we go, we just want to plot all of these numbers. So 2.5 will go up to 8, reading the scale carefully. There's that one. 7.5 goes up to 24, that's just here. We then have 13, 11 and 4. So 13, 11 and 4 just down there. And again, they're all plotted on the midpoints. Now from there, we just do a dot to dot. So the first point to the second point. We then want the second point to the third point. And again, just like a dot to dot. And there we go. There is our frequency polygon, drawn with nice straight lines using a ruler. And there we go. That's literally it for a frequency polygon. Just need to remember to draw on the midpoints. Okay, our next question. We have a farmer has a field in the shape of a semicircle of diameter 50. The farmer asks the fencer to build a fence around the edge of the field, and the fencer tells him how much it will cost. So it's £29.86 per metre of fence plus £180 for each day's work. The fencer takes 3 days to build the fence. So that's important there. The 3 days is relating to this £180 that we're going to have to pay per day. So straight away we could write that bit down, 3 times 180. And if we type that into our calculator, that comes out as 540. So that's part of the cost. We just have to work out the distance that the fence needs to go around this field, and then we can work out the cost of that too. So for this one, let's have a think. We have 2 formulas for circles. We have the area is equal to pi r squared. And of course, if we were needed to work out the area of this field, it is a semicircle, so we would need to divide that by 2. But in the case of putting a fence around the outside, we're actually going to need to look at the circumference. Now that part of the circumference there, we'll use the formula. Circumference is equal to pi times the diameter. But of course, it is only half of a circle, so we're going to need to remember to divide that by 2. I'm going to just write here, divide by 2 next to it, just so I don't forget. Once I've worked that out and I have the curved part, I also have this straight line here. Of course, that is just 50, but I do need to add that on as well because I have that part of the field which will need the fence too. So for the circumference, I will do pi multiplied by the diameter, which is 50. At the moment, I could leave that as 50 pi, which does come up on my calculator anyway, and I think that's easier than writing down all the decimals, particularly as I now need to divide it by 2 to get the length of the half or the semicircular part. And again, that comes out as 25 pi. Now at this point, I probably do want to start sort of drawing that in. So 25 pi, or writing the full decimal down, but I do need to add the 50 to that because we have this length as well. So up to you. If you want to write down the full decimal because you're more comfortable writing the decimals down, that's absolutely fine, but I need to add the 50 on. So I'm going to add the 50 on as well. Let's just do plus 50, and in total that gives me, let's just write down the total length. So the total length is 128.5398163 meters. Now, there's a couple of ways that you could actually consider this next part. We could multiply that straight away by £29.86. However, in real life, if it's £29.86 per metre, well, we're going to have to buy 129 metres because 128 isn't going to quite fit around. We'll have that gap of half a metre. So we just buy a little bit extra and we'll pay for that extra half a metre. However, technically, it doesn't say here that you necessarily have to buy a full metre or anything like that, but we just sort of can assume that. So in this circumstance here, we'll round it up to 129 to make sure we have enough. And now I can do the 129 multiplied by £29.86, which we can type in on the calculator, times £29.86. That comes out as a total cost of £3,851.94. And we need to not forget that we had this labour cost up here as well for £180 for each day's work. So we still need to add the £540 on that we had up there, and we add it all together. Now, I've written column addition there, but I am just going to click plus 540 on my calculator, and that gives me a total cost here of £4,391.94. And there we go, that's my final answer. That's what I want to put down here on my dotted line, £4,391.94. Now that is a circle problem there, of course, using the circumference formula, and obviously halving it there because we had a semicircle. But of course, make sure that you are still very, very happy with your area formula as well, as if circles is going to appear on an exam, it could be an area question, it could be a circumference question. So just make sure you know really well the difference between the two, particularly in these context questions where it's talking about a fence around the outside, and just making sure you know that that is about the distance around the outside, which is what the circumference is. And there we go, this was a semicircle, so we did have to divide it by 2 and find the total length, and then found the total cost. So a really good sort of functional real life question. This next one here is looking at expanding and factorising with quadratics. So when expanding a double bracket, we have 4 multiplications to do. So here we do the first 2 multiplied together, and that is 3 times 2, which is 6, and an x times an x makes an x squared. We then have to multiply by the negative 4 as well. So 3x times negative 4 is minus 12x. We then move on to the positive 1. So 1 times 2x is 2x. And 1 times negative 4 is minus 4. So we should get these 4 pieces here. Now we have to simplify, and that is combining these middle 2 pieces. So minus 12, add 2, and don't forget you have a calculator. You can just type minus 12, add 2, particularly if you're not as strong as you'd like to be with negative numbers at this point, but just type it in the calculator. So minus 12, add 2 is minus 10. So minus 10x, and then minus 4. And there we go, that is my quadratic, add it together, and again, just double check on your calculator, negative 12, add 2 is negative 10. I'm happy with that, so we'll move on. When we're factorising a quadratic, sometimes we will have numbers or x pieces in the middle. You can see over here on the example where we just expanded, we have this x piece in the middle. However, on this question, there's nothing in the middle. Now that can only happen in one scenario, and that's when the brackets that were expanded were the same numbers in the brackets, but one was a plus and one was a minus, because they cancel each other out. So here, when we are factorising this quadratic, and typically we'll look at what 2 numbers times to make 16. So you can have 1 and 16, you can have 2 and 8, or you can have 4 and 4. And it's just about recognising that this is one of those scenarios that's called a difference of 2 squares, where the 2 numbers are the same. So here we have the x at the start of each bracket. They both have a 4, and all we do is put the different symbols in each bracket. It doesn't matter which order you write them in, so you could put the x minus 4 first if you want, but there we go, x plus 4 and x minus 4, and there is my factorised quadratic. Remember, there could be a question very similar to this. You could have something like x squared plus 6x minus 16, and in this scenario we're still looking at these same factor pairs, 1 and 16, 2 and 8, 4 and 4, but in this scenario we're trying to make plus 6, and that can only be made using the 2 and the 8. So that would be slightly different. It still looks the same, but we'd have x plus 8 and x minus 2. And of course a completely different question, but just shows the differences between the questions that you could have and this difference of 2 squares question. And I actually think if a difference of 2 squares is the one that appears, that's a really nice one because it looks very unique comparatively to the others. So our next question is looking at a column vector. Now this question here says to draw and label the vector a minus 2b. Now that means we actually need to figure that vector out. Now a is nice enough, that's given to us. We have 5 and 2. 2b though, we do need to work out, and we are going to be taking that away. So to find 2b, all I need to do is take the b vector and multiply those numbers by 2. So 3 becomes 6, negative 1 becomes negative 2. So that's the vector that I need to work out, and of course we have a calculator. So I can type these in. I've got 5 take away 6 on the top, that gives me minus 1. And I have 2 take away negative 2. So I'm not going to make a mistake here with the double negative because I can just type it into the calculator. I've got 2 take away negative 2 and I get positive 4. There we go, of course, because a double negative just makes a positive. So it is just 2 plus 2 on the bottom, which is 4. So that vector there represents a movement. On the top it represents left and right. So minus 1 is 1 to the left. And 4 on the bottom is up and down, and that's 4 up. So I just need to draw a line which does the movement, 1 left and 4 up. Now if I draw a dot somewhere, let's imagine that's the start of where we're moving from, and I can pick anywhere as long as I have enough space to go 1 left and 4 up. So if I draw sort of guidelines in, 1 to the left, 1, 2, 3, 4 up would take me to here. So to draw this in, I would just connect those together with a nice straight line, draw an arrow in that direction, and if you want you can label it. You don't necessarily have to unless it says to, but there we go, that would be the vector, 1 left and 4 up, and I'm just going to label that a minus 2b. And there we go, there is drawing a vector and using the column vectors to actually find that movement. But there we go, that was some column vectors. Question 29 says Farah invests £7,000 for 2 years in an account paying compound interest. The rate of interest is 1.5%. Work out the value of Farah's investment at the end of 2 years. So with compound interest, or when you're looking at depreciation, which is where it goes down instead of up, you can actually just find the multiplier that you need on your calculator. So when we are looking at interest, it's going up by 1.5%. So on our calculator, we can do 100 plus 1.5, which is 101.5. I will link the video in the description that shows you how to do this, but you can just press the percentage button on your calculator. And 101.5%, if you type it into your calculator, comes out as 1.015. And that is the multiplier that we need. To get that, you'd literally just type in 101.5, normally press shift and there's a percentage button on your calculator somewhere. And again, I'll link the video so you can see what mine looks like. But there we go, we get our multiplier. Now to increase by that amount then, we take the amount of money, so £7,000 times the multiplier, or you can just type in times 101.5%. You can type it in either of those two ways. There we go, we can type it in like that, or using a multiplier like this. And then we just want to incorporate the amount of years. This is 2 years, so we put a power of 2, either after the percentage or after the multiplier. So let's just type it into the calculator, 7,000. I'm going to use the percentage version, 101.5% squared. And that gives me the total amount of money now, which is £7,211 and 57 pence. It is 575, so you could round it up to 58 pence. It's absolutely fine to leave it either as 57 or to follow the mathematical rules of rounding and just rounding that up to 58. Either answer would be fine. Just read those questions very carefully. Does it say the value of the investment, or does it say the amount of interest? This one's only worth 2 marks, but if it did say the amount of interest, perhaps you get an additional mark here by subtracting that original amount of 7,000, which would leave us with a total amount of interest of £211 and 57 pence. But there we go, that was some compound interest. Now we have some volume of a cylinder. Now it says here, this shows an empty tank in the shape of a cylinder. The cylinder has a radius of 15 and a height of 43. Water flows into the tank at a rate of 0.56 litres per minute, and then it tells us that 1000 centimetre cubed is equal to 1 litre. Now this is a conversion that you do want to learn. Sometimes you might be given it, sometimes you might be not. So do learn this conversion here, 1000 centimetre cubed is equal to 1 litre. It says to calculate the number of minutes it will take to completely fill the tank, and give your answer to the nearest minute. Now, to look at the amount of litres, or the space inside, we need to look at the volume of a cylinder. To get the volume of any prism, you get the area of the cross-section, which in this case is a circle. So in this case, we do need our area is equal to pi r squared formula, and we'll start by working out the area of that circular face. So that gives us pi times 15 squared, and feel free to either write down the decimal for that, or just to write down 225 pi, which is what it's showing on my calculator. There we go. So that is the area of the circular face. To get the volume of the prism, you multiply that cross-sectional area by the distance that it passes through the shape. In this case, it is the height. So we would multiply that by 43. We're going to get quite a large number now. And that, for me, again, you can write this out as a decimal, or you can leave it in terms of pi, but that comes out as 9,675 pi, or as a decimal, it comes out as 30394, so 30,394.90892. So that is the volume of the cylinder, the area of the cross-section multiplied by the height, or the distance that it passes through the shape. And again, knowing to use the area of a circle formula in this particular question is the really key part there. Now it says here that the water flows at a rate of 0.56 litres per minute. However, at the moment, this volume that we've worked out is in centimetres cubed, as we were dealing with centimetres. So we do need to convert that into litres. To convert it into litres, there are 1000 centimetre cubed in every litre, so we're going to divide by 1000. So I still have that number on my calculator. I'm now going to press divide by 1000, which just hops that decimal 3 jumps to the right, and that comes out as 30.394,90892, and that is now in litres. So now that we have the volume in litres rather than in centimetre cubed, I can now figure out exactly how many of these 0.56 litres are going to fit into that. So I've got this number that I keep having to write down with lots of decimals, but I'm going to write it down again, 30.394,90892. I want to know how many of these 0.56s fit into that, because that's how many fit in per minute. So I'm going to divide that by 0.56. So I'm going to just, on my calculator, press divide by 0.56. And that comes out as 54.27662308 minutes. Now the question here does say to give your answer correct to the nearest minute. So it's 54 minutes. After that is a 2. So my final answer would be 54. And there we go, that's how many minutes it's going to take, correct to the nearest minute, to fill this tank with water at a rate of 0.56 litres per minute. Always go back and check your answer here. We've done the area of a circle, which was 225 pi, times it by 43 as that was the height. We got the volume in centimetre cubed, divided it by 1000, which turned it into litres, and then it told us that 0.56 litres per minute was the fill rate, so divided by 0.56, and that was 54 minutes in total, correct to the nearest minute. And there we go, there was the volume of a cylinder. Now our next question, we are moving on to one of the toughest here, we have a simultaneous equation. Now when I'm solving a simultaneous equation, I look at the coefficients of y. You might be different, you might look at the coefficients of x, and that's fine as well, not forgetting that the 1 there is in front of the y, and I want to make those numbers the same. To make the coefficient of y the same, here I would have to multiply the bottom equation by 3. Now I'm still going to rewrite the first equation even though I'm not changing it, because I just want my two new equations written next to one another. So there we go, that's the top equation, haven't changed it at all. The bottom equation, 4x times 3 is 12x, minus 3y is equal to negative 3, timesing everything by 3. Now, I just remember, if it's the same signs in the question, you subtract. Here, we have different signs, so if there's different signs, we're going to add them together instead. So as they're not the same signs, we are going to add them. So I'm going to add these two equations together. You can always write down different signs, add, something like that, just anything that helps you to remember what to do in this scenario. So with different signs, 12x plus 2x gives us 14x. The y's cancel out, that's the whole point of this. And then when we add together 10 and negative 3, again just type it in on your calculator, 10 plus negative 3, that comes out as 7. We now want to know the value of 1x, so we'll divide by 14, and 1x is going to equal 7 divided by 14, comes out as 0.5, or you could write that as a fraction if you want 1/2. So there we go, that is the first part of the question, and the large majority of it. We've got one of the solutions, 0.5, and it does tell you on the answer line there, look, we also need to find the value of y. So you need to pick one of the equations. I tend to always pick the one that has the plus symbol in, if there is either with a plus symbol. So I'm going to pick this equation here, and the 2x becomes 2 times now 0.5. Now 2 times 0.5 is a really nice one. We can just type it in on the calculator, and that is equal to 1. So 1 plus 3y is equal to 10. We can then solve this equation for y by subtracting the 1. When we subtract the 1, we get 3y is equal to 9. And then dividing by 3, because we want to know the value of 1y, we get 1y is equal to 3. And there we go, that is our final answer for y. So x was equal to 0.5 and y was equal to 3. Okay, so we're going to move on to our final question. So our final question here is looking at some trigonometry. That's going to be our final one. So here we are working out a missing length. Now when you are working out a missing length, again, regardless of what we're looking for, we want to write out our SOHCAHTOA formulas. So SOHCAHTOA, and we want to label the side lengths to see which formula we need to use. Now here, instead of putting an X on the diagram, it says work out the length of AB. A to B is this length over here if you want to label it, and that length is opposite the angle that we're going to use. So that is called the opposite side. So we have the opposite, and we have the longest side of the triangle, which is called the hypotenuse. So in this question, we are not using the adjacent side. So I'm not going to label it. I'm going to now find the triangle that has the O and the H in, and that is my sine triangle. So to work out the opposite side, I'm going to cover up the opposite in my formula triangle, and it tells me I need to do a multiplication. So I need to do sin times hypotenuse, essentially is what that says. Now, when we press the sin button, it opens up a bracket. Now that bracket is to remind you to stick the angle in there so that your calculator knows which triangle we're looking at. Don't forget to close the bracket and before we times it by the hypotenuse. So we're going to times it by 16. And we're going to type that in. So sin 38 multiplied by 16. And that gives me a length 9 point, and it wants it to 2 decimal places. So let's first write it down here. 9.850583, a few more decimals. But of course, if it wants it to 2 decimal places, we have a 0 there after the 85. So it's 9.85 as my final answer. Just remember, if you are looking at different triangles, which of course you will be, then you might have to label 2 different sides. So I take the approach, I just label the side I'm given and the side I'm looking for, and it just helps me to very quickly identify which formula triangle I need to use. If you are looking for an angle in a question, so for example, let's imagine this question gave us the 9.85 and it asks us to work out the angle of 38. Well, in that case, you would cover up the S, and it tells you to do O divided by H. However, if you do 9.85 and you divide it by H, which is 16, it will not give you the answer of 38. And that's because you need to do the inverse of sine in your calculator. Typically, you have to press Shift first, and it will bring up sine minus 1 and open up a bracket, and that bracket there is where you put the division in. And when you put that division in, you will get 38 degrees. Of course, we've rounded the 9.85, so it's not going to be perfectly 38 if you type that one in there. But if we type that in, you'll see it's a good test here to work in reverse to make sure you can do that step as well. If you type that in, you'll see you get 37.99 and a few more decimals, so very, very close to that 38 degrees. But there we go, that's only if you're looking at working out an angle. Again, I'll link all the videos in the description for these different aspects of the topic as well, so you can check those out. But there we go, that is the end of this exam paper, and that is the end of our practice videos for paper 3 for this year. So there we go, hope you enjoyed that video, hopefully it was useful. Don't forget to check out the description for all of the links in there. And before I finish, of course, just want to wish you the best of luck for your exam, and please don't forget to come back on results day and let me know how you get on. But otherwise, best of luck for your exam, and I will probably not see you on the next one. So there we go, that'll be our last video for this year, looking at our paper 3 revision. Now hopefully you've got your revision under control and you're making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.